Given the question, consider the function f of x is equal to 2 sine x minus 1. Sketch the graph of f for 0 is less than or equal to x, which is less than or equal to 360 degrees. So here we are just given the range of our axis, of our x-axis. Then write down the period and amplitude of f. Then write down the range of f. So what we need to do here is to sketch this graph. So to make it easier, we draw a table which has x values, so for us to sketch this graph, we have to draw a table that consists of x values and the y values, and we know our y value should be 2 sine x minus 1. So this is 2 sine x minus 1. So we have 0 degrees, because they say our range from 0 to 360, 90, 180, 270, then 360. So what we do, we punch on our calculator this value, 2 sine x. So on the value position of x, we substitute with 0. For example, we say 2 sine 0 minus 1. This will give us minus 1. Then for 90, 2 sine 90 minus 1, we get 1 minus 1 minus 3 and minus 1. So now let's see how to sketch it. So we draw our Cartesian plane like this, with values 1, let me see, mark it like 1, 2, and 3, minus 1, minus 2, minus 3. So from there, we are being said, you can see this minus 1, it shows us that our graph is being translated 1 unit downwards, meaning this 0 line is being translated 1 unit down. So what you can easily do, you can draw your imaginary new 0 line as minus 1 like this, so that you can have a clear picture of what is happening on your graph. So let's go to the first coordinate, 0 and minus 1. 0 and minus 1, it's here. Then 90 and 1. Or let me mark the x-axis. 90, 180, 270, and 360. So we have 90 and 1. It's there. Then 180 and minus 1. It's here. Then 270 and minus 3. Somewhere here. Then we have 360 and minus 1 up there. So our graph will look like this. Then we turn. This is our turning point. Then we go up. So this is our new graph of 2 sine x minus 1. Then the next question is asking, write down period and amplitude of f. So our period here, you can see it takes how many degrees? Here we still have 360 to 0. So it takes us 360 to complete our cycle. Or you can check the value here, the value of b, which is the coefficient of x here, is a 1. So your period is 360 degrees divided by 1. You still get 360. Then our amplitude. period is 360. Amplitude, now we said this is our new zero line, so we check how many units are there from this zero line to the maximum point, or from the maximum to from 0 to the minimum point, but we can use this one. So we're from -1 to 0, we have 1 unit, then 0 to 1 we have 2 units, so our amplitude is a 2. Or you can just check the coefficient of your sine x, gives you the amplitude, showing you that it's a 2. Now let's see the last one. Write down the range of f. So for range of f, we need to find which one is our minimum point and which one is our maximum point. So our minimum point is this one, which is -3. Or you can determine it from the table. The least number is the minimum point. So we are from -3 to a maximum, which is a 1. So for our range, we say -3 is less than or equal to y, which is less than or equal to 1. Or you can write it in another notation, which is the bracket form. Say y is an element of -3 up to 1. Consider the function f of xe is equal to negative cos x plus 1. Sketch the graph of f for negative 360 degrees up to 360 degrees. Write down the period and amplitude of f. Write down the range of f. So I need to sketch this graph first, then we determine period, amplitude, as well as the range. So here we need to draw our table. We are from negative 360 degrees. This is negative cos x plus 1. So negative 360. Then we have an interval. We can use interval of 90, 90, 90. So from there we go to negative 270, negative 180, negative 90, 0, 90, 180, 270, 360. So we punch these values of x. Position of x is substituted with the negative 360, 270 until 360. Let's substitute negative 360 on the calculator. Negative cos negative 360. I'm getting 0. Then for the other one, I'm getting 1, 2, 1, 0, 1, 2, 1, finally a 0. So now I want us to have to sketch. So we draw our Cartesian plane. Let me centralize it. Position 0, 90, 180, 270, 360, minus 90, minus 180, minus 270, minus 360 degrees. So our graph is shifted 1 unit upwards. You can check that class one, it shows us the shift. So let me mark the x value, the y value is 1, 2, 3, minus 1, minus 2, minus 3. Since this is shifted 1 unit upwards, let me draw this. New horizontal line. Then first coordinate is minus 360 and 0. Then I mark minus 270 and 2. Sorry, and 1. It's in this line. And minus 180 and 2. There. Minus 90, 1, 0, 0, 90, 1, 180, 2, then 270, 1, 360, 0. So our graph is like this. That's our graph of cos minus cos xc plus 1. Then the next question is asking for period and amplitude. Period, you check the coefficient, this value before x, there is a 1 there. So our period is equal to 360 divided by a 1, we get 360 degrees. Then our amplitude we check this one, there is minus 1, but say if the sign is negative, whether it's negative or positive, your answer stays positive because amplitude is the distance, so you can't measure distance in negative units, so we just keep it positive. So our amplitude is 1. Then lastly, we have to find the range. Range of f is equal to we check our minimum value, it's 0, maximum it's a 2. So 0 is less than or equal to y, which is less than or equal to 2. Consider the function h of x is equal to negative 310 xc plus 2. Sketch the graph of f, write down period, write down the range of h. So in this case, we want to sketch this graph of negative 310x plus 2. So we can draw a table. So for this one, we can use an interval of 45, 45, 45. So from negative 180, then we say plus 45, we get negative 135. Negative 90 plus 45, you get negative 45. Plus 45, you get a 0. And plus 45, you get 45. Plus 45, you get 90 degrees. So these are degrees. Then from there, you punch it on the calculator by substituting x with these values. So first value, after substituting, we get a 2, then followed by minus 1. This one is giving me an error. Then we go to 5, then I get 2 minus 1, then this one is an error. So let me mark where I'm getting an error with an X. So when you are getting those errors, those are what we call the asymptote lines, where your graph must not cross or touch. So if you punch it on the calculator, it will show you an error. So what we need to do now is to draw our Cartesian plane. So we have 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4. Then we have 0 degrees, 45, 90. Then we have minus 45, minus 90, minus 135, minus 180. So we have the asymptote lines, which is x is equal to minus 90 and 90. So we mark the asymptote lines with dotted lines. This side is like this. Then the next step, remember, this graph is shifted 2 units upwards, plus 2. So we can translate our 0 line 2 units up. So we'll find it in this line. Let me make it a solid line so that we will not confuse it with these asymptotic lines. So the first coordinate is minus 180 and 2. Minus 180 and 2 is here. Then we have minus 135 and minus 1. Minus 135 is this one, and minus 1 is somewhere here. Then we have minus 90 is an asymptotic line, so we don't do anything there. Minus 45 and 5. Minus 45 and 5, somewhere here. Then we also have 0 and 2. Then we have 45 and minus 1. Then 90 is an asymptotic line. So our graph will look like this. It starts here. Then, sorry, let me push my point a little bit here. It's due to my board. This is our graph, then this side is like this. So this is our graph of tan. It's just like an overstretched S. So that's how we sketch a tan graph, given a set of x values from negative 180 to 90. So it's not always guaranteed that the range will be from negative 180 to 90. It can change anytime. So you just apply the same techniques to sketch the other types of tan graphs. Then the next question is write down the period. Period of this graph. Remember I said period is determined here. So period of this one is equal to 180 degrees divided by the value of b. Our b is a 1, so we divide by 1, we get 1. Our answer stays 180 degrees. Then write down the range of f. Range, it's now from, our y values keeps on extending, going down and up. So our range will be, is y an element of real numbers? Or you can say from negative infinity to positive infinity.